Because he'll call me by name.
I got an emailed a couple of questions, well actually the same questions. So let's look at section 2.1. The question about the socks. There it is. Now mine is different than yours, and I filled these in earlier. So let's talk through it and see how you do it, because everybody has a different number of pairs of socks in their drawer in this problem. Let's make it a little bigger so I can see it. So in my problem, I have 2 pairs of black socks and 2 pairs of blue socks. So 4 pairs of socks. That makes 8 socks in this drawer. To guarantee one match, then, that should be the same for everyone, right? How many socks would you, well, I have it on the screen. Okay. You need 3 because the first 2 might be 1 black and 1 blue. So you need 3 to get a pair for sure. Then to get 2 matched pairs, does everybody have the same question there also, to get 2 matched pairs? Because that will be the same for everyone as well, right? Because you get 3 socks and for sure you have a pair, but you could have 2 blue and 1 black. And when you pick another sock, maybe you get a 3rd blue. So then you'd have 3 blue and 1 black. So 4 socks isn't enough. But then when you get 5 socks, well then you'll have either 2 blue and 3 black, or 4 blue and 1 black, or 5 black. Okay, or you could have the other way around with colors. So 5 to get 2 matched pairs, but then this one you'll have to think through because this will be different for all of us. So if you have the 2 pairs of black socks and the 2 pairs of blue socks like I have, then you just think, well, I want to get a black pair, but I could just keep pulling blue socks out accidentally. Okay, so if I just kept pulling out blue socks and then I run through all the blue socks, then at that point I would have to pick black socks. So at that point, if I pick 2 more socks after I get all the blue socks out of the drawer, then I'll have for sure a black pair of socks. Now I could get a black pair of socks on the first 2 socks that I draw, but for sure after you pick out all your blue, so count how many that is for your problem, and then add on 2 more socks, then you'll have a pair of black socks. Does anybody have any questions? Yes?
Yeah, of course, you said a different example, but here it's that there's 22 pairs.
22 pairs.
11.
11.
I understood if I want, I mean, I got the middle one right, but the way I understood it is to get a black pair, you need to pull 13 out. Because then you pulled all the blue socks out, meaning you could only also pull out 2 more black socks.
Except you were thinking in terms of pairs. Remember, you're pulling 1 sock at a time. So how many blue socks do you have? Not how many blue pairs of socks, but how many blue socks?
22.
Yeah, 22, and then get 2 more.
Oh.
So then it'd be 24 altogether. Okay, if that doesn't work, then see me after class and we'll figure out what happened with it. Okay.
All right.
Anybody else have questions? Any questions from chapter 1 that you want to go back and look at? Okay. Well, let's pick up where we were before with the Fibonacci. Oh, yes.
So I was doing like the example questions, and the penny for your thoughts one where the emperor, I don't know if that's on the homework.
So the read, study, practice?
It's called, yeah.
Where
The penny
to go?
for your thoughts one. I think it's like the last.
So was chapter 1 yet?
It's 2.1.
It is
The
2.1.
example question.
Okay. Practice chapter 2.
I think it was like the questions at the end of chapter 2.1. Because I didn't know if that was going to be on the actual.
Okay, so there are some extra, well, this one looks different than what you were suggesting, but there are extra homework problems on Wiley Plus that you can practice on, but I didn't pick some of them because they're too hard, and I didn't pick some of them because the way you would answer them I didn't know if you would have the right answer, but because of the way you had to enter it, Wiley Plus might not recognize that you had the right answer. So you only have to do the ones that are required for the assignments that I assigned, and those are the type that you'll expect to see on your homework. I mean, on your quizzes.
Okay, because like the one where like the emperor asked is like modest.
Can I put it up here to show everybody? Would that be okay?
Yeah,
You would
because
print it
like
out? Okay.
yeah, because I was trying to figure that out because I like to do the practice ones before I get to the homework just
Oh.
to see.
Do you care if this is over on the overhead? Or
I don't care.
Okay, it's okay. Okay.
Because I was sitting there trying to figure that one out. I was like, I really hope it's not an assignment because I can't figure it out if I was right or not.
Okay, so you do have 4 chances to answer each question also on your homework. So you could try 2 or 3 times, and if you aren't getting it right, then ask in class too. So you don't have to feel like you have to practice before you practice,
Oh, okay.
unless you want to. So this one was penny for your thoughts. Let's see if I can make it come in better. 2,000 years ago, a noble Arabian king wished to reward his minister of science. Although the modest minister resisted any reward from the king finally forced him to... Here, let me make this a little smaller. Finally forced him to state a desired reward. So you printed out the book, and these are printed out from the book.
Yeah.
Also, I actually have this right available printed out as well. I looked at this question and I like it, but the way that Wiley expected you to put it in as an answer, I didn't like that, and so that's why I didn't pick it as an assigned problem.
That's good.
Yeah, it actually gets to be quite a big amount, and you probably figured it out. Well,
Because I was doing the math.
Yeah.
And I was sitting there like.
you
oh.
said you can do the math and figure it out, but then the way that it expected it to be input on Wiley was awkward, so I just didn't do it. Any other questions? Okay,
So for the
Yes.
sock one,
the sock one.
I understand, guarantee a match, then you wouldn't have to have the entire 122 pairs.
No, to guarantee a match, correct. You would not have to have the entire 22 pairs. So to guarantee a match, when you had 22 pairs of blue socks and 22 pairs of blue socks and 22 pairs of black socks, you need 3 socks. Because as you're picking them out of the drawer, you're going to pick either a black or a blue one each time. And so you could get 1 blue one and 2 black ones. That's a pair. Or you could get 3 black ones. Or you could get 1 black one and 2 blue ones. So when you have 3 socks, there's no way to get 3 socks without getting a pair. Whereas when you only have 2 socks, you could have 1 blue and 1 black. It's like our pigeonhole principle, where you have a blue room and a black room, and you're putting the socks in the room. And once you pick 3, you're going to have a double up. Okay.
Great.
Any other questions?
All right, I'll just see, maybe I'll ask after class too. So
Okay.
like you said.
If it's still not clicking, we can talk. Okay. Well, we were looking at the Fibonacci numbers, and we'd seen how we would write them out with just ones. So if you have your notes there, we'll go back to that page. So what we were doing, we were making ratios of the Fibonacci numbers and writing them with just ones. So we were able to do that with just ones. We split up the numerator into a sum And then we made two fractions. And in the second fraction, the denominator could be the sum before. So here I had a 2 in the denominator. So I took this 2, and I had written out 2 over 1 before. I wrote it as 1 plus 1 over 1. So that replaced the 2. Same thing when we split up the 5/3. We split that up into two fractions. So we had a 1 plus 2/3. And then the 2/3 was not quite like the 3/2. It was flipped the wrong way. So we flipped it. We put 1 over 3/2. And the reason we did that then is so that we could take this 3/2 and replace it with what we had written 3/2 earlier. So that wrote the 3/2 as the 1 plus 1 over 1 plus 1 over 1. Same thing with the 5/3. We split it up, flipped so that we had 5/3, rather 8/5. The 8/5 we split up and wrote so that we had a 5/3 in the denominator, 1 over 5/3. And then that 5/3 could be replaced. So we wrote the 1 plus 1, and then in the denominator we put that whole series of 1s. So I asked you to think about, when you left, what would the 100th ratio look like? So we did the first ratio was 1 over 1. Second ratio, 1 plus 1 over 1. Third ratio, 1 plus 1 over 1 plus 1 over 1. Fourth ratio, fifth ratio. What would the 100th ratio look like? Anybody? Be the same, right? Okay. Yep. And then do we see enough pattern to tell us how many ones we would write down? We see enough of a pattern going to know how many levels we're going to put in this?
100.
Yeah, 100. Good. Yeah. Because this ratio had 5. This was our fifth ratio. We had 1, 2, 3, 4, 5. Fourth ratio, 1, 2, 3, 4. So we have a pattern going. We didn't actually find the 100th Fibonacci number, but we know what the ratio would look like. It would be 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus, and then I'll put dot, 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 1 plus 1 over 1. So, and then we can write off to the side 100 levels. We don't want to actually write 100 levels, but we can write off to the side that there's 100 levels. Well, this, how far could we go? We're looking at the 100th ratio. What is the, I mean, how many ratios are there of Fibonacci numbers? Yeah, infinitely many. So there's infinitely many. So this could go on forever. In fact, it does go on forever, and it has a name. Good. Yeah, it is. It's called phi. It's pronounced phi, but it's written the Greek letter phi. Phi. So there's your Greek letter phi, and phi is equal to 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1. And then this time I'll just put dot, 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 because we're not going to stop ever. So unlike the 100th level where we went with 100 levels of ones there, the 100th ratio, this one is going to go on forever. So the dot, dot, dot just keeps going. It doesn't end in a 1 over 1 like the 100th ratio did. So you know your pi, you've heard of pi before. Pi is the Greek letter. Well, that stands for the number that's approximately 3.14. phi is another special number in math, and it stands for this continued fraction that goes on forever. Now let's write this phi down again, because now we're going to mark it up a little bit. So we'll write it down again so that we can mark it up. And what we're going to do is I'm going to circle part of it, this part. So you have the 1 off to the left and the 1 in the numerator, and I'm circling the part underneath. And I'm asking you, what is this part in purple? What is the value of that? 1 plus 1 over 1 plus 1, the part in purple. Anybody know what that is? Yes?
Isn't this what equals phi?
Yeah, exactly. It's phi. Yeah, so the part we circled in phi, that's part of phi, is still phi. Phi is part of itself. Phi is equal to 1 plus 1 over itself. 1 plus 1 over phi. So the answer to what is this is phi. So phi is an interesting number. It can be written as a continued fraction of ones, and it's part of itself. It's within itself. It's one of the interesting aspects of infinity that we see there. Well, we can figure out the value for phi, because this is just a little equation now that we can solve using algebra. So we'll do a little algebra here and solve this. So we'll start with the equation. Phi equals 1 plus 1 over phi. And then if you remember from algebra, whatever you do to one side of the equation, you do to the other side. So we'll multiply both sides of the equation there by phi. So I'm multiplying both sides of the equation by phi. So on the left-hand side, you have phi times phi, which is phi squared. On the right-hand side, we have a phi times a 1. So that's phi. And then you also have the phi times the 1 over phi, so this distributes. So phi times 1 over phi is 1. So this is just an equation like you've solved in math lots of times. This is just a quadratic equation. It's a quadratic equation like x squared is x plus 1. Okay, so in algebra class they used x's, not phi's. But this is the same problem. So to solve that, we want to get a 0 on one side. So let's get a 0 on one side of the equation by subtracting 1 from both sides. So subtract 1 from both sides. Remember, whatever you do to one side of the equation, you do to the other. So we have phi squared minus 1 equals phi. And then we'll subtract phi from both sides. So phi squared minus phi minus 1 equals 0. I think it's supposed to be a straighter phi. I think my phi is starting to look like a C. Okay, but it's supposed to be a little straighter than that. Okay, so we know how to solve this using the quadratic formula. So your teacher probably had you memorize the quadratic formula using the song the tune that goes to Pop Goes the Weasel. Yeah. Does anyone remember the quadratic formula? X is equal to. Oh, X is.
B squared minus 4AC all over 2.
Hey, good job remembering. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So the a, b, and c are the numbers in the quadratic equation that you're solving. So here a is 1 because this is a 1 times phi squared, and b is negative 1 because negative 1 times phi. and C is -1. So we're not solving for x, we're solving for phi, so we'll fill that in. Phi is equal to -b, so that's the opposite of -1, so 1, plus or minus the square root of -1 squared minus 4 times a times c. So 4 times 1 times -1. All over 2a, 2 times 1. So phi is equal to 1 plus or minus the square root of 1, because the -1 times the -1 is +1. Remember, a negative times a negative is positive. So here you have a -4 being subtracted, and that becomes +4. So phi is equal to 1 plus or minus the square root of 5 over 2. That's two answers. That's what the plus or minus means. So phi equals 1 plus the square root of 5 over 2, or phi equals 1 minus the square root of 5 over 2. We'll just put those in our calculator and take a look at what those are. Now, if you have a scientific calculator, you can put that all in your calculator at one time. If you have a simpler calculator, you'll start with the square root of 5, figure out what that is, and round it off. In a scientific calculator, you would put parentheses around the numerator so that the whole numerator is divided by 2. So we have it with a plus, and now we'll check it with a minus. So the little squiggly equal sign means approximately, because we rounded off. Anytime you take your calculator value and round it off, you've approximated. So this is an approximate value here. And here we have the exact value in the square, with the square root is the exact value. Now, the one that's -0.618, that's extraneous. Do you remember we looked at these ratios? I had each row work on a different one. Okay, and when you looked at your ratios, you were getting about 1.6. So this is the exact value for phi, 1 plus the square root of 5 over 2, and you could find as many decimal places as you wanted from that. And the approximate value is about 1.6. So this has a lot of math, and you're thinking, man, I don't know if I could remember how to do those quadratic equations. That's okay, you don't have to. Okay, but here's what we'll put stars by what I would want you to know from this. Okay, so let's put a star by the approximate value for phi. Let me get a better marker here. Okay, so we're going to know the stuff by the star. So know the approximate value for phi, know the 1 plus the square root of 5 divided by 2 exact value for phi. And then we're going to move up on the page. So let's go up here. Know that phi can be written as 1 plus 1 divided by phi, which is kind of interesting. And recognize it as a continued fraction of ones as well. So those are what I would expect you to know from that. I wouldn't expect you to just have solve for phi on your own, unless you want to. If you're a mathy person, then it's kind of fun. Do you have any questions so far? Well, let's go back to the basics and make sure you remember how to find the Fibonacci numbers. So that's a quiz question I would give you as well, to write the first 15 Fibonacci numbers. So who remembers what we were starting with for the Fibonacci numbers? Yes?
1/1?
That was the ratio. That was the ratio. And then the Fibonacci numbers.
It was 1, so you had 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5.
Right. So that was the part that we did before the ratio parts. So the Fibonacci numbers themselves, 1 is how you start, and then you start adding, like you said. So go ahead and do that. So the 1 plus 1 is 2, 1 plus 2 is 3. So please take out your calculators if you need it, and go ahead and write out 15 Fibonacci numbers. So your first 15 Fibonacci numbers, we would have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610, and dot, dot, dot. If you say these to put yourself to sleep at night when you're suffering from insomnia, it's not too bad up to here because of the matching digits, and then after that it's like, oh, if you're still awake then you need some sleeping pills, okay? All right, so what we have for most sections is a life lesson. The life lesson with the Fibonacci numbers that your author gives you is: unexpected patterns are often a sign of hidden underlying structures. So we took a look at the patterns in nature, and they led us to the math, the arithmetic, and we worked with those patterns, and we found that there's these other interesting patterns that result from the ratios. And we'll see that those ratios lead us to things like interesting geometrical progression. So we'll be looking at that with the Fibonacci numbers in the geometry section. Well, for now, though, we're going to look at some ideas about how can you write non-Fibonacci numbers non-Fibonacci numbers as in terms of Fibonacci numbers. How can you write non-Fibonacci numbers in terms of Fibonacci numbers? So 15. 15 is not a Fibonacci number. How could we write it in terms of Fibonacci numbers?
Would you?
How about you, because you haven't answered yet today? What were you thinking?
I remember reading this in the chapter. You just count down from the thing. So you do like, you have to do like the least ones. So you could do like 13 or 2. You have to do like the ones that like are less than 15.
Good. Yeah.
Yeah.
So 15 fits in here. So you said, okay, let's write 13 plus 2. So you take the biggest Fibonacci number you can, 13, that goes in, that is part of the sum, and then that leaves 2 more, and 2 is a Fibonacci number as well, so you can write 13 plus 2. That brings us to the point that every number that is not a Fibonacci number can be written as a sum of non-consecutive Fibonacci numbers. Every number that is not a Fibonacci number can be written as a sum of non-consecutive Fibonacci numbers. And this is also something I would be asking you to do on a quiz. And so we're going to get a little practice at that as well. Let's pick out a number and do that. How about 30? Okay, so we're going to take 30. And we see where it fits in the Fibonacci numbers sequence here. So 30 would fit in here between 21 and 34. So I'm going to pick 21. Okay, so now I need 9 more. So now I look at 9 in my list. Yes.
Do you always go back if it's like you don't want to go over, so you always go backward?
Good. Always go backwards.
Okay.
Yep. Yes.
Be 21 plus 8 plus 1.
Perfect. Yep. Yep. So we picked the biggest one we can to start, and that left 9. 9 falls right here, so the next biggest one we can use is 8. And after that, we needed 1 more. Here, try this one at your desk. So 50. So you might need your calculator. Anybody want to tell what they found? I didn't see you yet. Yeah, 34. And that's the first one, but not 21, because that would add to 55. Okay, then I saw your hand.
I did 34, 13,
13. Okay, good. So once you pick 34, then 50 minus 34 is 16. So then you put your 16 in your list, and you're like, okay, that falls in here, so I'm going to pick the 13. And then 34 and 13 is 47, so you need 3 more. I do have a question, though. The question is, why non-consecutive? Non-consecutive means they're not in a row, right? There is one exception to this. One Fibonacci number, one number 4 is an exception to this. But the numbers bigger than 4, you won't need. You can write them as sums of non-consecutive Fibonacci numbers. So see if you can think about it for a while. when you picked out the 34, were you sure it wasn't going to be 21 next? Or why, when we picked out the 21 for the 30, once we picked out the 21, why were we sure it wasn't going to be 13 next? Why were they not going to be consecutive? Yeah.
Well, because when you add up, like, up to there, like, equal what you're looking for.
So when you add the two next to each other, they're going to be too big. Yeah, good. Yeah. So when you add the 34 and the 21, you're past the 50. But when you added the 21 and the 13, you're past 30. So you picked where your number fit. Well, the two numbers before it add to bigger than where your number fit. Okay. Well, that's going to play a part in a game we're going to play now called Fibonacci Nim. So we're going to play Fibonacci Nim. And that is actually how I would ask the question about the non-consecutive Fibonacci number sums, because I would ask you to do it in terms of Fibonacci Nim. So I'm going to actually tell you the strategy for winning Fibonacci Nim before we play it. Maybe I'll tell you after we play one round. Okay, we'll play one round. Let's get it all set up. So where do we have the things that we need here? Okay, so we have these toothpicks, and I want you to know I sprung for the good toothpicks, not the plain brown ones, okay? All right. So I'm going to send these around, and students at home, you can go find some of these. Take a small bunch. You don't have to count them out. So I'm just going to take a small bunch, then pass the toothpicks on so we can try and get everybody going here. Once you've got your bunch, just count and make sure you have at least 20. Okay. If you have like 50, bring some back so there's enough for everybody. All right. So I'll send these around. And you'll be doing this in groups of 2. So only one in your group of 2 needs the toothpicks, and I'll help you get in a group of 2 if you're not in a group of 2. Either someone behind you or someone next to you, okay? Here's, send these around. So can I have you two work together, and then you two, and you two? Okay. And then you two can work together. You two, would that be okay? So the back row, you two could work together at your table, and then how many is left? Okay, how about you two work together in the back row, and then you two, and then you're left. Oh, there's 2 and 2. So I thought there was going to be an answer. So I'll come back and play around with you with different sticks, okay? Okay. We just need. So only one person in your group needs sticks. And once you have your sticks, once you have your toothpicks, group them up into sets of 5 because it's easier to count them, and you'll need to know how many you have. So if you group them into sets of 5, it will be easier. And by the way, this is where you need to do your class activities. So you'll want to be taking a picture of these. You can do that as soon as you have your toothpicks.
Yeah. You have to probably go backwards.
So with the class activities, can we send a photo? Or is it was the assignments, right, that you don't accept late work?
Right.
But with the class activity,
I don't accept late class activities either.
Okay.
But you can just take a photo and submit it.
this one.
Yeah, this
the last
photo right
time
now.
I forgot it, and I thought it was not worth it, but I was here the day I did it, so.
Okay, set an alarm. Set an alarm on your clock, on your phone to remind you every Sunday night.
Yes, but also class activities cannot be 3.
I forgot
You're
that.
done.
Not, no, not
Okay.
really. But I do drop 3 because I know things happen. So,
Okay, I thought it was just assignment, so I go in the syllabus.
well, there's so much at once on the first day down here, yeah.
So then I looked at it and I said.
Okay, how are we doing for toothpick distribution? Who needs toothpick?
And she was like, it's fine.
Split them up into bunches of 5, okay? Bunches of 5.
Sorry. And I didn't really have the waffle style until at the very end after I was like, oh, there's more on this one. I was like, there we go.
Okay, I'm going to be player 1, and you're going to tell me what to do, class. Okay, so the way that this works, I'm going to take some toothpicks, as many as I want. But then, after I pick some toothpicks, you're going to tell me how many to pick, and you can tell me to pick between either 1 or up to twice as many as I pick. After that, we go back and forth doing that. You can always pick between 1 and twice as many as the person before you. The way you win is to be the one who takes the last toothpick. So you want to be the one taking the last toothpick. So you'll need your Fibonacci numbers out. I'll tell you why in a little bit. Okay. So I'm going to pick 2. Okay, so I picked 2. Now somebody tell me between 1 and 4 how many you picked. What? 3. Okay, so I'm going to take 3 now. So I can take 3 for you being player 2, and now I'm player 1 again, and I can take between 1 and 6, and I'm going to pick 2. Okay, so now you can tell me to pick anything between 1 and 4. What do you want? Someone tell me. 2. Okay. 2. So this time you told me 2. I'm going to pick 3. So I have an option between 1 and twice what you did. So I'm going to pick 3. So you can pick up to 6 this time. Now we're getting close. Remember, you want to be the one to pick last. So someone tell me how many to take. 2. Okay. 2. So I'm going to pick 1. Okay, so that means you only have a choice of 1 or 2, because I just picked 1. What are you going to tell me?
1.
1? So I'm going to pick 1. Okay, now what do you, now you're kind of sunk, right? Because if you pick 1, I'm going to pick 2 and win. If you pick 2, I'm going to pick 1 and win. And you only get a choice of between 1 and 2, because I took 1, so you only get up to 2. So there's a winning strategy there. So if I followed it right, I was bound to win. And the strategy is to be the first player, to not have a Fibonacci number of sticks. So look at your sticks and make sure they're not a Fibonacci number. If they are, take 1 away. So don't have a Fibonacci number to start. And then think of the number of sticks that there are as these sums that we've been doing. And pick this one. Think of the number of sticks that there are. Write them as a Fibonacci sum, just like we've been doing, starting with the largest number you can and going down smaller. And pick out the smallest one in your sum. So this time I picked out, let's see, we had 20 sticks. I thought of 20 as 13 plus 5 plus 2, and I picked 2. And you have to do that at every stage though. So take turns being player 1 and see if player 1 can win. I'll come around and see how you're doing.
I'll go first. Would you like one or 2?
Okay.
I guess.
Now you can take the one.
You can go 6.
Go for it.
I'll put the directions up again so that you can remember what you can do.
Who was player one?
You can take 1 through 6.
We were so close to one.
See, my strategy is not have a strategy. You just might have some.
Oh, we're not, no more sign. Yeah. So I took 4. Okay, so you could.
If you're stuck, raise your hand.
So I was doing assignments when
At least take one.
there were 3 that was one of them was literally a question about I was like, I don't know what that is. Then I looked it up and I was like, I'm gonna go to class. I did not do it.
You want to start over again?
I'm gonna take it. What is it that I can call it? I'm gonna take 1 to 6.
I don't have enough time to think about the sequence of every single number every time.
Please have 3 seconds.
I'm going to take 1.
Wait, is it for what? Like, you took 6 and then you took 1.
You took 2.
Yeah, I really didn't have to be clear. I can't believe I won. I never win. It's all the time. So satisfying.
My turn.
Yeah, but I think you should take 3. Yeah, so I can take 1. Then you can't take 1.
No, like it's double. You can take more than
I've already lost.
Yeah, I think you saying no to it. I'm gonna take all of it.
How's your player one doing?
We're still the first one since player one.
I think you're not gonna have a hard time catching up unless you make a mistake. Okay, so how many are there?
Looks like 7.
I'm still new to here. I've never been.
You swiped the game out from her, didn't you? She took control. I think you're gonna be close. If you're playing like this player one strategy. Okay. Is that? Oh yeah.
Yeah,
But now you're gonna have to maybe you can be player one next time again and help her learn how. Okay. Okay. How is it going back there?
I think that either way.
So I was trying to pull, so of course you're playing 1 to 6.
You took 3, right? Okay, so where are you at? I was second.
And
I'm just taking the last one. So there's 3 left with my turn. Okay.
And I can take up to 2, because it's doubling, right? Yeah. But then he would wait to do the last one.
Well, let's try another, let's start again. Who's gonna be player one this
And I
time?
can, you can be player 1.
Okay, we'll make sure
So,
you have 1 and 2.
yeah, but
Well, the thing is, yours by
I was
2.
counting my every time it ends up, the sum is never.
So technically I just
I took 3 and
it was somewhere
then I can
before.
take anything.
I think I can't remember. I don't think it's like when it gets closer to small.
I'm winning.
But the bigger it is, I just like
Take a picture of something.
I don't know.
Like, I have OCD or whatever.
I mean, I
But that's
consider
really like, if you had
but,
OCD, you would definitely tell
like,
everybody
think of it like
that
that,
far,
teaching
and
But
then,
think
like, I have,
of
like,
it as like the sequence of her right now is like 27 to 29,
a little bit of it, but like,
Whatever.
like I had the here
20, 29, 21 plus
if I touch
plus
something that's yeah, I have it cold. So if I touch something that breaks down,
every time I get there,
how many steps are there after each pull,
it's so
and
bad.
it would be the number in the sequence in that.
I would push down and then you want to have their
Yeah. I feel like a win. None of this feels like a win.
I got like
So hopefully everybody had a chance to win as player one. If you want to stay and play again, I'm going to stay and help and make sure everyone knows how. Online students, feel free to email me your sequence of play if you want to verify you're doing it right. I'll see you on Monday. Have a great weekend.
science homework and then I get done by 1, so you're done at 8.